I need to go close the door. Hey, we're live.
We are live, and welcome back to SP Channel. Tonight we have Tate Plays with us. This is just a random talk. We're just kind of, shooting the crap. This video will probably be deleted later, so you guys can watch it or not. It's a short-term thing. What's up, brother Tate?
Not much, brother. Is that a little better for you?
I mean, yeah, I can hear you pretty good.
All righty.
So, oh, go ahead, brother.
Oh, I was about to say not much is up at all.
So we was going to have this magical debate about the shape of the earth, were we not?
Oh, yeah. I'm going to play the devil's advocate and say it's flat.
But it's not. It's totally curved. Like, for instance, if you start walking at any point on earth, provided that you can climb really well and swim really well, you will eventually end up back where you started.
But if it's got a curve and you can see a light for 3 miles, right?
Right.
We know you can see light up to 3 miles.
Right.
If it's got a curve and you set that at let's say, a foot tall, right?
Right.
Okay. Well, wouldn't that curve prevent you from seeing the light at 3 miles away?
Well, I mean, that depends on how you work the math out. We do know that the curvature on the earth presents us with a horizon. I mean, there are several reasons why we know the earth is round, let alone that there are satellite images of the earth spinning.
I mean, Albert Einstein even said that the earth could be stationary.
Well, that was before Albert Einstein created the general and special theory of relativity. He thought that all of space was static. That was how Einstein changed physics when he presented the special theory of relativity, because he made the general theory of relativity, right? And there were a lot of physicists that were like, well, there's problems here, here, and here. And then Einstein was all like, okay, well, here's my special theory of relativity. The universe is constantly in motion and expanding. And so this was the thing about Albert Einstein that a lot of people don't know. His first theory of relativity, which I believe was the general theory, proposed that the universe was static and everything was where it was, and that the universe was not expanding.
Well, I mean, even with this newer one, you can break the theory of relativity.
Well, you can break the theory of relativity, but the reason that a lot of science is based on relativity, that relativity is the standard model of particle physics. It's what particle physics is based on, really. Yes, you can break relativity, but it defies our understanding, especially in the areas of quantum physics, because within the confines of a black hole, you would assume that there's a lot of mass. The mass goes in. But here's where relativity kind of breaks in a black hole. Where does the mass go? Because you've got this singularity. And if that black hole were to explode, it's not going to discharge mass like what you think. It's just going to discharge a bunch of force. Inside a black hole, from what we can assume, there's only one atom. That's what a singularity means. It's through incredible pressure been fused into a single atomic mass. And when that black hole explodes, you're going to get one atom that comes from it. The rest is going to be force of the explosion. So the break in relativity is, where does the mass go? Where does it go? You know what I mean?
Well, theoretically, there is white holes.
Of course. Theoretically, there is white holes. And I have to be honest, I tend to lean toward, the mass has to go somewhere, and white holes and wormholes are a pretty good solution. But we've never observed a white hole. We've only theorized about them. The thing about white holes is like, I tend to lean toward, yes, white holes are a thing, and that's what's happening. But we can't prove that. But let alone, we can't prove relativity beyond a shadow of a doubt either.
True. But, I mean, Einstein's grand theory can be broken under certain circumstances.
Mm-hmm.
His original theory was that the universe was static and that the earth was static, right?
Right. His original theory was that, everything in space is where it is and that it's not expanding. And when you base particle physics along with that, you end up with misunderstandings about things like redshift. You're aware of what redshift is and how the color of a light's frequency changes depending on how far the light has traveled through interstellar space.
Oh yeah.
Okay, so the deal was, it's like, oh, but if the universe isn't expanding, Mr. Einstein, then how do you explain this, and this? And that was when he created the special theory of relativity, which stated that the universe was in fact expanding. And it allowed for the thing about the special theory of relativity is the standard theory of relativity, the general theory of relativity, it doesn't account for quantum physics. Now, here's the thing. A lot of people can say, well, since relativity is not proven and quantum physics aren't proven, well, here's the thing about quantum physics and the fact that if quantum physics are proven or not. There are certain aspects of quantum physics that have been proven in a lab. They're like, yeah, this is what happens when we do that. Um, Ultimately, we don't know why. We don't know why relativity seems to break under certain conditions. We don't know why when superfluids are cooled down to, near absolute zero, that these superfluids, their properties will change. They will seem to defy gravity. They will climb out of a glass. Um, we don't know why uh, when a black hole absorbs all of this mass and creates a singularity, we don't know where all the mass goes. Sure, it was compacted tightly, and you can believe, if you want, that all of this mass was compressed into a single atom. But by quantum physics, that's not possible. That's where relativity breaks. You cannot take all of this mass and shove it into a space the size of a single atom. The going theory with black holes is that through such pressure of the gravity of a black hole, what's actually occurring is entropy, because black holes, of course, mess with time, right?
Yeah.
Right. So the idea here is the incredible entropy around a singularity actually causes the matter to dissolve into energy. And this energy actually feeds the black hole, causing more gravity.
Hmm. So it's getting its pull from whatever it absorbs.
Oh, consider it like this. What is the main property of inertia, my brother?
I mean, you got velocity.
Well, inertia is a property of mass. Velocity is a property of mass as well, but velocity is kind of different than inertia. Inertia is the principle that says an object in motion tends to stay in motion, right?
Oh yeah, ain't that
So,
Newtonian?
no, you're talking about Newtonian physics. Now, the deal with inertia is consider this. People are like, where does the incredible force of a black hole come from? Well, consider that the inertia of the gravity itself has caused the black hole to absorb this matter, this mass, right?
Mm-hmm.
Okay. Consider that it is a force that just won't stop, right? It's like if you throw a baseball, right, in your yard and it doesn't really hit anything, the only thing that's going to cause it to stop is when the gravity finally pulls it to the ground, right?
Mm-hmm.
So the deal with a black hole is that it keeps pulling in this matter, and I feel that the inertia of the matter is the key here. It's like, let's say you're driving a car down the road and you're doing 110 miles an hour, right?
Mm-hmm.
You can slam on the brakes, but you're not going to immediately stop,
Okay.
right? So this is where I feel like the incredible intense gravity of a black hole comes from, the inertia of the matter it has absorbed. It's not going to stop because of this incredible inertia force, right?
Mm-hmm.
I mean, that's just the way that I feel about it. But let's continue on, because this was a topic, as we discussed earlier. You want to be the devil's advocate and proclaim flat earth theory.
Mm-hmm.
Okay. Now, I'm not here to pick on people who believe in flat earth theory. I don't feel like excluding anyone, because I feel like everyone should have a chance to learn more about science. Um, I'm not going to tell these people they're wrong because ultimately you can believe anything you want to believe, and that's your
Mhm.
prerogative to do that. Um, my questions are more along the lines of where are these flat earthers coming from? Why do they believe that the earth
Oh,
is flat, and why do they stand by their belief so wholeheartedly?
I can give you that one, man. They're going by the Bible belief about the four corners of the world,
Right,
and they're also going by in Genesis when he was talking about the creation of the earth, where he took the two domes,
right,
put them together, and he separated the firmament.
right. Well, these, when he created these domes, to me, and this is just my thoughts, to me, when you take two domes and you place one amidst the other, like it describes in the Bible, then what you have is a sphere,
Yeah,
you know.
yeah, but they believe that the sphere actually, okay, the land's flat, it has a bottom.
Right.
They believe the sphere, which is the atmosphere, goes around it in a circle, but the actual land flat.
Right. Well, I mean, I would be tempted to entertain these theories. And like I said, I'm not here to ostracize people for what they believe because there are people who believe in the hollow earth theory. And I've always had trouble discerning the differences between hollow earth theory and flat earth theory. Are they the same theory?
No, see, with flat Earth theory, think of a 2D model,
Yeah.
like you're looking at a 2D map.
Yeah.
Now, when you pick up that piece of paper, you've got it underneath there. And
Yeah.
underneath there, there's nothing but the firmament.
Okay. So I guess I have to throw it out there. Are flat earthers basically trolling? Is that what's going on?
No, these people actually believe this, dude. Uh,
Okay.
Look, I'm not going to throw no insults, but with the amount of statistical data and calculations, it's hard to believe that the Earth is not anything but flat. The way that I'm saying this is it's not flat, but I've got to be the devil's advocate here.
Oh,
So,
I totally get where you're coming from. I mean, somebody's got to stand up for that side of the debate, and right. I salute you for that. My deal is that we look out into space, we look out into the cosmos through astrology, through astronomy, um, basically through telescopes, through radio telescopes. One of the most common shapes that we find throughout the universe is a sphere. If you release a bubble into the air, it's a sphere. If if you even throw water, out of a glass, it's going to turn into droplets, a sphere. It seems to be a common shape found in the cosmos. You
uh,
look at the planet Mars. Is Mars also flat? Is the moon also flat? Is it just Earth that they believe is flat?
well, see, what they believe is that NASA has some really good skills with CGI
Right.
and actual constellations. They don't believe we've ever been to outer space. And they believe the outer space trips that we have now are actually shot in pools of water in secret locations.
Again, I back that with scientific data. Some people may not believe that we've ever been to outer space, but I don't even think that those people could deny that we have satellites in space. That's where we get our radio signals from. That's where a lot of us get our television signals from. Some of us even get our phone signals from satellites. And that's going to lead us into, some quantum theory later. But for right now, I want to say that the whole idea of how a satellite works, right? If the Earth were flat, the satellite wouldn't work at all because it has to orbit the Earth, right? And the way that satellites broadcast their signals is they've got this general area that they broadcast to, right? Okay, so if the Earth was flat, when this signal was beamed down, it wouldn't hit the places that they were needing it to hit. And they focus a satellite with mathematics. The Earth would have to be round. It would have to have a circumference for a satellite to even work.
Well, see, this is where a flat earther would tell you one of two things. They would either tell you that they are beaming the satellite supposed signal.
To a radio tower, and then they're spreading it out.
They're either doing that or bouncing it off of the atmosphere, or they're using underground
Okay.
setups.
So another big question that I would throw to flat earthers would be, is the sun flat? Is Mars flat? Is Neptune flat?
No, they believe that all of that is CGI that we have. The actual shapes are varied.
Okay. So they believe that the shapes of the planets. Now, I will grant a flat earther this. To say within the confines of mathematics that the earth is round, the earth is not perfectly round. The earth is more or less an oval shape.
An egg.
Yeah. Okay. But here's the deal. Just in experiments that we have with gravity here on Earth, when you take some clay and you spin it around on a pedestal and you put your hands upon this clay, does it turn into different shapes or does it turn round?
Well, it depends on how you mold it.
It definitely depends on how you mold it. But here's the thing. You would almost have to assume, looking at the moon, of course, there's no telling what a flat earther thinks of the moon. I've heard lots of theories about the moon, from the moon being hollow to the moon being a construct of man that was put there to deceive. I've heard so many theories about the moon, but my question is why would a flat earther in all of the cosmos look at all of these other planets and assume that they're all CGI? I mean, you look at a star, it doesn't look like a little flat line. It looks like a round dot. You look through a telescope, and here's another thing. It's not just CGI. I mean, surely some of these flat earthers have actually looked up at the skies with the telescope. You can look at the planet Venus through a powerful enough telescope. And these are home telescopes. These are telescopes you can go to Walmart and buy for $50, and you can actually see the moons orbiting around Saturn. You can see, objects orbiting around Venus.
To my knowledge, they do not deny such heavenly bodies, but what they do deny is the fact that man is capable of getting to them because we cannot cross through the firmament.
Aha! Now we're getting to the meat of the issue. So the flat earther believes that space travel is an impossibility.
Yes.
Okay, why?
Because the firmament is basically like a giant dome, a shield.
So the firmament in the flat earther's mind is like a force field that prevents us.
Oh, well, I'm not for sure because each one has different theories on what it actually is. There's a whole lot of theories. But to me, I believe the firmament is water.
I mean, I would almost go with you on that. I know you're studied in science like I am, but just going on the definitions of word, I would think the firmament would be the land within the water. You see what I'm saying? The firm.
It could be. I mean,
but that's just my thoughts on it.
But they believe that this is built in a dome around flat Earth.
Well, now,
we can't leave and nothing can come in.
I'm going to be fair to you here. I mean, according to the Bible, the earth was built in that way. It was built within a dome. It was brought together. I totally get that. But so is it a safe assumption to say that these flat earthers just steadfastly refuse modern science? Is that what's up?
Well, you and me both know that conspiracy theories have turned out more to be true than not.
Well, I mean, I don't know. I do know that several conspiracy theories did turn out to be true. As a matter of fact, and this is just to throw the information out there to any listeners that we have, and I think you're well aware of this too, Brother Tate. There was conspiracies about UFOs for how many endless decades? And was it not earlier this year or late last year that the U.S. military released a couple of videos of what they even claimed was a UFO? Now, in their terminology, a UFO doesn't mean aliens. It doesn't mean abductions. It doesn't mean technology from outer space. It's an unidentified flying object. But now here's the thing. We've got some of the brightest minds on planet Earth working, with NASA, working with these observers, working with the military, and these people can't figure out what the heck they had on that video. And I saw this video. If I edit this video later and put it back online, I'll probably edit a piece of that video footage over. It looks like a craft that flies in ways that you've never seen. It turns on its side. It turns upside down. Nothing stops its flight pattern. It can do things that we just could not do. And this was a video released by the United States military as they chased this thing down. They call it a UFO. They designate it an unidentified flying object.
Yeah, there's also two more classes of that. There's a USO, unidentified
Submerged object.
And there's a ULO, unidentified lying object.
An unidentified lying object?
Laying.
Oh, laying?
Yeah.
Because, I had a friend in school, and he used to lie a lot. He was like an unidentified lying object. No,
well, see, that's where the English grammar and stuff gets a little, because if I use the past tense of lay and use lie.
Yeah, totally. And that works. I just had to pick on my friend.
Yeah. But, yeah, man, I mean, there's things out there that they don't understand. And on top of it, these flat earthers, man, they've been lied to so many times and found out about conspiracy theories so many times.
Yes, and that is a topic that I wanted to discuss with you, was the conspiracy theories. You have to realize that when you come to conspiracy theory, right, there's this old saying, and that old saying is that it's nice to have an open mind, but don't have an open mind that's so open your brains fall out. The reason that I say this is, yes, some conspiracy theories have turned out after years and years to have some sort of merit. For instance, the top secret footage of the UFOs that were released from the military toward the end of last year, the beginning of this year. I don't remember exactly when. But you have to realize that there are so many conspiracy theorists out there with so many different conspiracy theories. I mean, for instance, there's conspiracy theories that believe Elvis is still alive, that Kurt Cobain is still alive, that Michael Jackson didn't really pass away. You have to realize that conspiracy theory is a slippery slope. At one point in conspiracy theory, a person can cross the rational and get straight up into irrational.
Elvis is still alive.
I mean,
so is Tupac. He's dropping an album.
But here's the thing about Elvis. People are very, very hopeful. Let's go ahead and say for a second that Elvis didn't die when people think he died. Chances are he's dead now anyway. He would be a really old man.
There's all types of conspiracy theories, but the ones that have been proven true have proven that the government has lied to us, spied on us, and they can't trust anything that's governmental, is what they're feeling like.
No, I totally get that. And to a certain degree, you can't trust. It's really hard for me to say this, but there are certain things that you can't trust about politics. And I think that everybody, even the people that would be listening could agree to that. You don't get to lead a country. You don't get to be super duper rich and have all this political power unless you've stepped on a few toes and crossed a few people. Because, I mean, it's not like that seat to lead a country is just wide open with welcoming arms. You're going to make enemies when you decide to lead a nation.
Oh, dude, if you're talking about the American presidency, it's always been run by cutthroats. The very first George Washington actually did cut throats.
Well, see, I mean, I'm not even talking about the current president. I'm just talking about politics in general. And what I say about that is this, if we do want to move into the current presidency, yeah, there's lots and lots of jobs given, and I'm a supporter of our current president. I am, but I'm not a supporter of Trump like some people would be. I'm not just blindly supporting Trump because he's Trump and he's so different. I'm supporting Trump because he's the current president. And to be perfectly honest, with all the stuff that they've said about Trump and all the things that Trump has done, I don't think Trump has made nearly the mistakes of some people we've had in office in the past. I feel like people are being overly critical on Trump and maybe a little harsh on him. Um,
Oh yeah, yeah.
you know, um, Give him a chance. I mean, the fact of the matter is, the election's over, right? And at this point, if you're not at least open to the idea that he is the president now, well, I mean, that would almost seem like you're against America. I mean, this is just in my, opinion. Like, you know, if you can't show support for Trump, at least show support for America, right? And I'm seeing a lot of people in these harsh political fights, to the point to where they just slam America and they talk these nasty things about the country just because Trump's leading it. It's like, here's the thing. Maybe our current political environment isn't what people would have wanted. But when you talk about America, you're talking about the common working person. You're talking about the families. You're talking about the brothers and sisters. You're talking about the cousins, the grandmothers, the grandfathers. That's the America to support. And whether you're a Republican or a Democrat, you should be supporting those people, your family, your friends, what's important to you.
Yeah, I agree to that 100%.
You see what I'm saying? So, like,
Yeah.
don't go so far off on this hate trip because you're not happy with the current political environment or our current president and start slamming America, because America is me. America is you. America is your father. America is the people listening. The guy that's in the White House right now, he's just the guy leading right now. He is not the symbol of what America is. We are the symbol of what America is.
What I'm saying is that guy, no matter what party he's belonged to or been affiliated with throughout history,
Yeah.
from George Washington all the way up, doesn't matter what side, Democrat or Republican, they all have been cutthroats in one way or another.
Well, I mean, I hate to throw it out there, but if people really, truly, bluely want to start nitpicking at history, I mean, George Washington, he owned slaves. And of course, back in George Washington's time, not only did he own slaves, but before George Washington was an American, he was a British soldier. Okay. You have to take into consideration that George Washington betrayed the military agency that he was working for, that he had sworn and made oaths to, and he betrayed them. Okay.
Yeah,
To work for America. So, yeah, we look at George Washington as Americans like he helped us so much, and he did. He helped us. He did. He helped us so much. He was George Washington, the father of our country. But people often forget that as a military soldier, he betrayed his own country.
yeah, that's what I'm saying. As a military soldier during the Revolution, when he had to fight to free the colonies, he literally did cut throats.
Right. And of course, there's with Abraham Lincoln, I really don't want to touch up on Abraham Lincoln because Abraham Lincoln is fairly well universally respected across the board. But a lot of people don't know this about Abraham Lincoln, but he wanted peace between the North and the South so bad that he wrote a few letters to the South explaining how he didn't want to abolish slavery, but it must be done for peace. So you have to consider that maybe that was negotiation, maybe that was politics, but he actually on paper notarized, said that he didn't want to abolish slavery. It just was something he had to do. So we look back on history through rose-colored glasses and think things were so great. It's always been a war zone being the leader of a country, as far back as it goes.
I'll tell you why he wanted to abolish, or why he wanted to abolish it. Why he wanted the war to end so badly that he would do away with slavery. Let me put it that way.
Okay.
And the reason was the death toll for the Civil War. Now, this was people from the North and from the South fighting on an ideology, brother against brother, father
Right.
against. Now, the death toll was 660,000 plus.
And you know, 660,000 people at that time in this country was a vast swath of the population.
Dude, it's the highest death toll we've ever had in any war.
Yeah, but you have to realize that, like, America's population back then, the numbers were a lot smaller. 660,000, that was like there was nowhere in America you could go where there were settlements and people. And, you know, half of the people were missing. Half of everyone in America died.
Yeah. So, with that much massacre over just such an ideology, dude, he had to end it.
No, I get that. I get that. And he did. But when I look back through history, I try not to look back through history through a set of rose-colored glasses, because
Oh,
lest that we forget, history is written by the victors, Brother Tate.
well, that's true. That's
I mean,
very true.
consider this. You know, I don't even like talking about the guy, so I'm not even going to mention his name. But there's a certain guy from way back in the 1930s who was this horrible, horrible person. Horrible, right?
Oh,
Uh,
yeah, you're.
yeah. We don't even have to. I don't mention him because, in my eyes, to mention his name is to give him power. And no, that guy deserves no power. But what I'm getting at is, had that guy won World War II, what would history look like today? There would be statues of that man.
Well, let's see. Considering that it was a fallacy of logic, anyways, that he went to war for such things that he did, because him himself
Right.
being an actual German Jew.
Well, see, fallacies in logic are not uncommon, even in today's world. I mean, I just want to go ahead and say, look at your flat earthers. If you look back at science, even as far back as alchemy goes, and I'm going to go ahead and start the bonfires for alchemy for you. If you look back through history, even as far back as alchemy goes, sharp divisions in opinion have always been there, and they've always caused strife and stress with people.
Alchemy is the forefather of science.
Alchemy is the forefather of science, but alchemy is not something that people in today's modern age should look upon with reverence. Okay. You cannot take an example like, well, alchemy said that there's this many planets and you have to worship the ethers, blah, 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 and use magic, blah, blah, blah. No. Okay. Alchemy was the beginnings of science, but science has learned a lot since the days of alchemy. You can't fall backwards on these ancient beliefs of alchemy and make them count for anything with relevance in today's world. Alchemy is responsible for the birth of science. Yes, that is true. But alchemy can teach us nothing. Alchemy depends on magic and deities and all of these different chemicals that didn't even have proper names. Any chemical that they didn't understand was called an ether. I mean, come on.
Well, I mean, there is unknowns in science till today.
Well, there are unknowns in science. And what's bad about that is even science has its flaws. Okay. Relativity is not a proven concept. They don't call it the fact of relativity. Evolution is not a proven concept. They don't call it the fact of evolution. They're called theories. So, with this, at least we're admitting with science that we don't have all the answers. But with alchemy, they covered up the answers that they didn't know with magic. Ooh, boogie, boogie magic.
Well, if you think about it, anything that can't be defined or explained through the natural laws of physics is therefore, I think, supernatural.
Paranormal.
Paranormal, supernatural.
So, yes, magic is just an archaic word for paranormal. We have different words. Magic has not disappeared. We just gave it a different name.
Yep.
I mean, it's true. Anything that alchemy couldn't explain was magic. Anything that science can't explain is paranormal. Same thing.
Same thing.
Same thing.
Same thing.
But, you know, we were getting into something, and I kind of wanted to touch on space-time just a little. I feel like maybe I'm wrong in this assumption, but I feel like people don't understand the connection between time and space.
Well, it takes you amount of time to travel a certain amount of space.
Yes, but the idea here between time and space is time and space are two sides of the same coin. They're the same dimension. Time and space are the same. For instance, entropy proves that time and space are the same. It's like earlier that we were talking with the black holes, like the force of the inertia causes the mass to entropy out into energy, right?
Yeah, which gets
Okay.
converted into more energy.
But what do black holes do, Brother Tate? They are massive anomalies within what?
Well, then space and time.
Exactly. So what would happen to these particles of mass that enter these massive anomalies of space and time?
Well,
They would entropy out.
Theoretically, if white holes and portals do exist, they could pop out at anywhere in space and time.
Well, now you know that I lean toward white holes being a thing. I support relativity to that point that white holes are a thing. But here's the deal with that. Even though I believe that white holes are a thing, there's no proof that white holes exist. And to someone that doesn't even believe white holes are a thing, like there's no reason for me to argue and debate with them that white holes are real, because from the ground up, relativity is a theory. It's not proven yet.
But I thought there was proof of a white hole
No,
creating
no,
mass for a few seconds and then disappearing.
no, sir. To my knowledge, and here's the thing, black holes are becoming something that we are accepting is there. However, because black holes do not reflect light and we cannot see them through radio telescopes, it's kind of like with the HIV virus. I hate to compare black holes to the HIV virus, but there is a parallel. The parallel is there's no blood test in the world that can tell a person definitively if they have HIV. The only way they can tell that if you do have HIV is certain enzymes in your blood reach these certain levels. So there's symptoms in your blood that tell the story of HIV if you have it, right? The same thing goes to black holes. You cannot look into space with radio telescopes, imaging techniques. There's no telescope powerful enough in the world to see a black hole, even if that black hole were just 2 feet away from you, because they do not reflect light. They are invisible. Here's the thing. When we look into space, we see all of this debris and all of these planets, and they're acting in particular ways like they're being slung around by an intense gravitational force. This is how we assume, oh, well, there must be a black hole there because look at all that stuff being slung around. That's how we know a black hole is there. Now, we designated them and called them black holes. In the centers of galaxies, they're supermassive black holes, right? But here's the deal with that. We've never laid eyes on one. We've never saw one, and anything you see when you think you're going to the net and you're looking at what is a picture of a black hole, that is an artist's representation. I hate to burst people's bubbles, but Tate does have a point. A lot of the pictures that you see of outer space have been doctored. They've been enhanced by artists.
Oh, yeah.
As a matter of fact, you can look this up. If any of you feel like it, you can look this up on Google. It is a great paying job to be an astrophysics artist that draws these representations of these planets. It pays oodles of money.
They either do that or make composite photos.
Even the composite photos, I promise you, you've never seen a composite photo of a black hole.
No, I was talking about the planets because, look, the planets are so large that even if they go 20 miles into outer space, they can only take a picture of a section.
Well, let me on the fabric of space-time. Let me just for a second give you my thoughts on physics. Now, you know that I've studied physics most of my entire life. Ever since I could learn how to read, science, since back in the days of Mr. Wizard and Bill Nye, science has been my brain candy. You know, I've studied it as far back as time goes for me that I can remember. Do you guys, of course, I know you do, Tate, but I'm hoping that the people listening may remember as well. One of the earliest physics lessons we were taught in school was the fabric of space time, to take this sheet and all of your little friends, they grab a hold of the sheet and you all pull. And then the teacher takes a basketball or a baseball and drops it on the sheet and it rolls toward the center of the sheet. And the teacher will explain that's how space time wraps around, planets and objects in space. Now, here's the deal. In my eyes, in my vision, in the way that I envision space through my studies of physics, here's what a black hole is. Okay. Take the fabric of space time and imagine it in your head. It's a thought experiment. Okay. Now take this sheet of plastic or this sheet and stretch it out from all ends as hard as you can. And then just pour a bunch of milk on it. Right? Pour this milk right on top of that sheet of plastic. Okay. Now, what happens to that milk? It pools in some places, it scatters out and streams out in others. Now, these places where it pools and globulates, that's mass, okay, in outer space. Mass attracts to itself because of the gravitational pull of mass. Now, when you get enough mass compacted densely enough, I feel like you get a black hole. Now, these are where these gravitational anomalies are coming from. You've got very dense matter creating these gravitational anomalies, and we call them black holes. Why would a black hole be at the center of nearly every galaxy, a supermassive black hole? Well, that's because at the center of nearly every galaxy, mass is coming together, just like the pools of milk globulated on top of that plastic sheet. Mass is forming together.
Back to the white hole theory. There was a gamma ray burst back in 2006, didn't fit with understanding of where they come from. Its duration was 102 seconds.
I'm aware of that gamma ray burst, and I've got to tell you, brother, I have a lot of opinions about that gamma ray burst, and you may disagree with them, but since you're the devil's advocate tonight, you just can. But all right, we've talked about the gamma interference background, right? We've talked about the gamma wall. I call it the gamma wall, but science actually calls it, the gamma wave interference.
Oh wait, you're going to go into your theory about green shift?
Well, I mean, I could, but here's what I'm getting at. All right, so people wonder how large the universe is, and they wonder if we can only see so far into observable space, how can we know how big the universe is? Well, here's the deal with that. When we look out with radio telescopes far enough into outer space, we get this background noise, and it's just all solid green. Now, we have termed this gamma radiation, and we believe that this gamma radiation came from the original Big Bang, right? And we determine how far away the gamma wall is from us, which, by the way, is 94 billion light years, okay? And we look at the curvature. As we look into outer space and we see this gamma radiation, this gamma interference, okay, we notice that it's curved. So we assume that the universe is spherical because the burst has a curvature to it, right? Okay, so we look at where we are, the planet Earth, we look at where the gamma wall is, and we know that we are 94 billion light years away from the gamma wall. Okay. So here's the thing. Well, people are thinking, well, if you're looking at the gamma wall in relation and distance to the Earth, how can you know how old the universe is? We don't have to know how far away the gamma wall is from Earth. When we see the curvature in the background radiation noise, right, we can formulate a circumference for that curvature. And we can say, oh, the universe is this big, right? Okay, so we get this circumference and we simply work out the math like, okay, if it's traveling at the speed of light, blah, 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 and it's been traveling for 94 billion years, then this is how large the universe is. It's all simple. Really, it's not complicated math either. It's simple geometry and a little bit of calculus. You look at the curvature of the background noise, the background gamma radiation, you work out a circumference. And in the circumference, you work out how long it traveled from the center, the very center spot, the singularity, to now. 94 billion years is what you come up with.
Yeah, but that would have to mean that the Earth is symmetrical and in a shape, or that the universe is in a shape that we know of and symmetrical to
Now,
that
here's
shape.
the thing about symmetry versus supersymmetry, Brother Tate. Symmetry is discovered in nature all the time. And you'll hear people argue, like, what? Symmetry's been discovered in nature? Look at a butterfly's wings.
Yeah.
Symmetry's all over the universe. Now, supersymmetry, on the other hand, is quite the elusive beast, and we have never observed it that I know of.
Actually, there is some guys who are through CERN that have some interesting findings on that.
I mean, even in quantum physics, Tate, supersymmetry is a problem.
Yeah, yeah.
Now, to cut this short for people who aren't thinking along the same pathways that I'm thinking here, just so they understand where I'm coming from, if you could find an example of supersymmetry, that would prove God exists. That's basically what supersymmetry comes down to. Because with quantum physics and our understanding of particle physics, astrophysics, quantum physics, high energy physics, supersymmetry just does not occur.
Well, see, there's a guy, crap, I can't remember his name, but I'll send you a link later.
All right, can you keep him busy while I run to get something to drink? I won't be but a second.
Oh, sure. I'll just go ahead and say this because you already know this. It's the guy who had Neil deGrasse Tyson rethinking his stuff. Anyway, there's a guy who had Neil deGrasse Tyson doubting his religious belief, which is atheism. And the way that the guy had him doubting it is because he had found supersymmetry, and in the supersymmetry, he had found a computer code. Specifically, a computer code that was predicted by a French guy in, I think, the 1940s, 1912, somewhere in there. And with this existence of the supersymmetry and the code in the universe, that therefore means that there's a programmer for our universe, which would be the big G, you know. So, I mean, it's one of those things where I'm glad to hear it, but I'm also not glad because it breaks a whole lot of scientific principles.
All right, brother, I'm back. Thank you.
Yeah.
And I missed all of that. So what were we talking about?
Oh, I remember James out of his name, but he had like 3 different names. And he's a doctor who are he would have a doctorate, most likely, or a PhD. But he's working through CERN, and he found supersymmetry in the universe, or claims to.
Now, here's the thing. Can he prove that he found supersymmetry? Because if he did find supersymmetry, the deal with supersymmetry is, as I explained earlier, it defies quantum physics. It defies relativity. Quantum physics states, especially through the observation effect, and I think we've discussed the observation effect at great length before, so I don't have to cover that. That supersymmetry is just an impossibility. If supersymmetry were discovered, that proves beyond doubt that there is a God.
Well, yeah, that's what I was saying. That's what the guy was saying. He was saying that not only did he find supersymmetry, but he found the code hidden in it. And the code is a computer code that was created by a French guy in the 1940s, 1912s, somewhere in there.
Well, now, this is where I wish we had Brother D here with us. If he's listening, I wish he would just jump right in, because D has a nice theory about code, and I tend to almost agree with that. I used to go around and I would say to people, why are our genetics coded if there's no coder? Why is there this code here and that code there? And Dee's theory on it is
Yes,
that the
God
code is,
did.
yeah, the code is there because that's how our minds work. We built the code looking at those things, and we built the code around what we discovered. So that may not even be a code. It may be we tried, it's for instance, in quantum physics, we've got all this math, right? But what if quantum physics turns out to be a bunch of bunk? What if relativity turns out to be a bunch of bunk? All those codes we think we have were just creations of our own, trying to explain it.
Well, if there is supersymmetry and there is a computer code to the universe, that means there's a programmer. If there's a programmer for the universe,
Absolutely.
well, that means that there's the big G, right?
Well, here's something else that I wanted to touch upon. Um, I don't want to bore people with my science, and I know that sometimes I do because, I mean, I dig really deep into science, man, so deep that some people just don't want to hear it. We were talking about the errant gamma radiation that you were talking about earlier, the one that didn't fit our gamma signature
Yeah, the single burst for 102 seconds.
from 2006. Yes.
Yeah.
Now I do know quite a bit about that, and I've studied up on it. I've read up on it. Scientists believe that this may be another bubble touching our own bubble, that it may be from another universe. Now, here's the deal about that. We know for a fact, at least we're convinced beyond doubt, that our own gamma radiation is what, encompasses our own universe. Now, when we detect gamma radiation that doesn't match our gamma signature, we can only assume it's from another bubble. So, in 2006, that was the biggest boon to multiverse theory. As a matter of fact, if you guys think about it, and if you guys, if anybody's really listening now, I can only assume they're as into science as we are. But if you really think about it, think back to before 2006. How often did you hear people, talking multiverse theory? It was around 2006, 2007 when scientists were convinced, yeah, multiverse theory is a thing.
I don't know. I think, well, of course, it's a little different than the actual theory, but I think there was a show called Sliders in the 90s.
Oh yeah, yeah. Multiverse theory's been around for a while, but the big boon to it was in 2006 when we discovered that errant gamma radiation. That's almost like the proof we were looking for. You know what I mean?
Well, it's also sparked the theory of white holes or what's the name of it? It's the proper name for Einstein Rosen bridge.
The proper name for an Einstein-Rosen bridge is a wormhole, brother.
There's a guy. There's a guy who predicted it. Hmm, I can't remember.
I mean, think about what a Rosen bridge is. You can't.
Schwarzschild's wormhole.
Oh yeah.
That was weird.
What's up?
Yeah, I think it's Schwarzschild's wormhole.
But I mean, here's the deal. The idea is I don't know. I mean, I study physics a lot, right?
Oh yeah.
I don't believe a wormhole would be possible unless you would have to have something like a ring singularity, right? For a wormhole to be a fact. Consider if you've got two baseballs, right?
Mm-hmm.
And now let's take these two baseballs and place them 15 feet apart. Now, let's just say through science or through some sort of awesome technology, you could give these two baseballs intense gravity like that of a black hole. Even if these two baseballs are pulling with all this intense gravity of a singularity, they're not going to just open up a wormhole. They're going to create gravitational waves, of course, but they're not going to open up a wormhole. The only way that I feel a wormhole could really be opened through a black hole would be through a ring singularity.
You're talking like a Kerr singularity.
Yes, a Kerr black hole. Yes.
Well, here's the thing: is I believe that a Schwarzschild's wormhole or whatever you want to call it could be created by a Kerr singularity. but you're not going to be pulling full objects out of whatever dimension you open it
No,
to.
you can't. We've actually discussed this at great length. The intense gravity of any singularity is enough to rip something apart at the atomic level. So anything that goes through a black hole is dead. Any organic material, any material really. I mean, you could take the hardest substance that you know of, diamonds, you send it through a black hole, it's going to be squished down into that singularity, um, and
Oh, yeah.
destroyed. So nothing really alive or living is going to pass through a black hole unscathed.
I believe the only thing that would come out of it is energy.
I will tell you this though. Here's an interesting thing about black holes. Um, your Einstein-Rosen bridges versus your supermassives, because the Einstein-Rosen bridges, he was dealing with planet-sized black holes, right?
I don't think. I think they were more like, I would say at most a portal, like a 12 by 12.
Right. Okay, so like here's the deal. Here's the deal. Now, at the center of the Milky Way is this supermassive black hole, and you know those are much, much larger, right?
Oh, yeah.
Okay, because of your relative size in comparison to a supermassive black hole, did you know that not only could you approach a supermassive black hole, you could probably swim around on its surface?
Hmm.
The reason for that is your relative size in comparison with its critical mass. Basically, you're nothing but a flea or a speck to it, and it, you get where I'm coming from with this.
It can't squish you because,
Because its force is just too massive and you're too tiny. Yes, sir.
wait a second. So wouldn't that put the force into the negatives?
No, because it's the force on a much, much larger scale, my brother.
Yeah, that's what I'm saying. If there's so much force, then wouldn't it be null or negative?
I mean, there's that possibility that it could be null or negative because, okay, we're fixing to tap into dark energy here. Now, let's get something straight that a lot of people get confused. And the reason that I straighten this out, dark energy and dark matter are different. I used to confuse these two myself. Dark matter is an unknown substance that we don't really know about. In science, when we call something dark, like dark energy or dark matter, we call it dark because light hasn't been shined upon that. The illumination of intelligence or intellect on that thing, we don't understand it. Okay, so dark matter, we don't fully understand it. Dark energy, we don't fully understand it. So you guys can take that to the bank. Anytime science uses the word dark, it's just a cover for we don't really know. Okay, now here's the thing about dark energy versus dark matter. Dark matter is a parallel form to antimatter. As a matter of fact, some people debate whether dark matter and antimatter are the same thing. They are not. But it's still a matter. It's a form of matter that we find using what is those chambers, the bubble chambers that they use in CERN looking for neutrinos?
Oh,
I guess yeah. Remember Gargamel, the bubble chamber in CERN?
I'm not for sure about that one, to be
Well,
honest.
that's the bubble chambers, man. They fill them up with liquid freon, and because of these massive chambers, the way that they're buried underground, they actually within this freon can catch neutrinos and observe them for split seconds. Um,
Wait a minute. So, okay, you're telling me that they're actively studying neutrinos
dude, they were actively studying neutrinos in 1976, man.
through CERN.
Through CERN, yes.
Hmm.
Oh, I can guarantee you this. This was part of the study that I had to study up when we did that other video.
Dude, why in the hell don't we have time travel already then?
We kind of do. I kid you not. People say that time travel is impossible, but what a lot of people don't understand about time travel is the idea of time travel the way you imagine it is impossible. It'll never be, right? You can't send something living, something biological forward in time. And for the record, we can't send anything backward in time. That may be an impossibility. But because of the way space-time works, we have been able to shine lasers, and we can shine lasers fractions of a second ahead in time. That's been done. And even though that's on an incredibly small scale that may never benefit man, it is possible.
Well, that's photons, though. Photons do that automatically.
Well, I mean, whether it's photons or not, when we can manipulate it and control it, that proves that it's possible. That proves the possibility of it. I mean, here's the thing. People want to write things off and they want to say time travel is not possible. But when we know that photons do it by their own nature, how can time travel not be possible? Photons are doing it. You see what I'm saying?
Well, see, there was a lady scientist. I cannot remember her name for the life of me. And I believe she was in Canada. She was doing some research on how light varies at different speeds and different temperatures and all this and that.
Yeah.
And she actually managed for a fraction of a second to hold light in place.
Yeah, to stop a photon in its tracks. I'm well aware of that. That required an argon gas chamber and lasers.
Yeah.
Yep.
Well, if we can manipulate time,
We can. I can give you an example of how we manipulate time.
I meant light. If we can manipulate light, which is photons, and they're connected to time, then why can't we manipulate time was the question.
Well, let me throw you guys something that'll blow your minds. To a certain degree, we have been manipulating time for quite a while. Consider this. A satellite in outer space, when they beam information to you, it is a certain distance away from you, right? So when they beam that information to you, they have to beam that information and they have to account for that several seconds that it's going to take to reach you. So if you're receiving information live on a satellite, right, or live from a satellite, you're receiving that information. They are accounting for time. They are actually using that same ability that, you know, when I told you that we can send lasers forward in time, fractions of a second, they're using that from satellites. GPS wouldn't work without it. Your weather radars wouldn't work without it. We've actually been manipulating time, at least as far as light and information goes, for decades. But when people think of time travel, they think of getting in a car or getting in some sort of a vehicle or even just walking through a portal. That may be impossible, and it may always be impossible. But we can send light information.
Well, all right. Let's just say you could take a particle, break it down to its basic components, turn it into energy or light, and send it to where you want to and reconstruct it.
That is teleportation.
Now, if we can send light or signals a fraction of a second forward or a fraction of a second backwards, why couldn't we?
No. I tried to make that perfectly clear. For us, I mean, we could get into string theory and discuss this further if you wanted to, because within the confines of string theory, backwards time travel could be possible. But for us, the way that the nature of entropy works, right? Time only for us, at least in this dimension, in our reality, only goes forward. It doesn't go backwards. It just does not. Okay. So backwards time travel for us in this universe is impossible.
But you do have theories on the nature of time that are other than linear.
Yes. Yes, but the theories that there are about time being other than linear, linear. Einstein, of course, proposed that time is relative, meaning that, you know, time changes. Okay. depending on your acceleration. I'll give you an example. Okay. And here's an example that you can search on Wikipedia. Here's an example that you can read up about. And guys, if you're the least bit interested in this science stuff, please feel free to go and read up. You can find all of this information on Wikipedia. It's there. If for some reason you were able to board a craft and travel at the speed of light, okay, for 10 years, okay, and you, for that whole 10 years, you traveled at the speed of light, okay, now I'm assuming that you left Earth, right, and you traveled for 10, maybe 20 years. When you come back, for you, because of your vast acceleration, only 10 or 20 years would have passed for you, right? But when you come back, everyone that you knew and loved will have aged 60 years because time passed differently for you than it did for them. That's what it means when time is relative. When you're traveling at near the speed of light, okay, your velocity, your acceleration causes the relativity in time to change. The ticks between the clocks go slower for you. The entropy upon the atoms in your body moves slower. When you experience sleepiness, when you experience tiredness, you experience time in a different manner than these people left back on Earth. So when you return, only 10 or 20 years has passed for you, but 55 to 65 years has passed for the people here on Earth. That is what it means that time is relative. And we can prove that time is relative. We use these same principles to focus and tune satellites and GPS.
Yeah, but there's certain things that break those theories. Not only the gravitation, not only the Big or Bose-Einstein condensate, um, but critical mass itself would break that theory because
Now,
if you were to speed a person up that fast and they hit critical mass, they wouldn't be a person no more, so they
well,
couldn't
first of
age.
all, let's take critical mass and let's break critical mass down for a second. People want to take the ideology between critical mass and they want to romanticize it like it's something completely ununderstandable. Critical mass, okay, is common nuclear physics. And I know that that sounds bad for me to say common nuclear physics, but I promise you, and I promise anyone, nuclear physics are a great deal easier to understand than any type of astrophysics.
Hmm.
You know, critical mass is what happens when the mass reaches such a point that the matter has to convert over into energy. All right. And this is what I was talking about earlier within black holes. Okay. Now we cause critical mass to happen by splitting atoms, you know, fusion and fission. And that's how we cause critical mass. Okay. But my assumption is under incredible gravitational forces like that of a black hole, that also would, you know, initiate critical mass. And that's where the matter's going. It's changing into energy.
Well, at near light speeds, the actual mass of an object it it turns over to energy.
Well, I do want to throw this at you just so you know, and this is something that people can check up on. And if I'm wrong about this, then please leave a comment, you know, guys. But as I understand it, they say that nothing travels faster than the speed of light. However, gravity is not a particle, it is not mass. It is a property of mass, but gravity itself is faster than light. That is a proven concept.
Well, there's another thing that's faster than light: dark.
Yes, yes, that is true. That's actually a topic that I had discussed that the speed of dark is faster than the speed of light. And this is an easily proven concept. Um, I'll give you guys an example. There's a video. And I know you guys are on YouTube now if you're listening. So please feel free to search up a video. I would recommend my video about the speed of dark, but there's a much, much better one made by a guy who's much more talented in these areas than I am from Vsauce. His name's Michael from Vsauce, and he made a video about the speed of dark, and that's where I got my idea from. And honestly, I would recommend, you know, Michael from Vsauce's video about the speed of dark. And here's the idea. Physical matter, as it approaches the speed of light, breaks down into energy. It's like what I was saying, you know, earlier. The reason that time is relative for that person in the spacecraft, if he's traveling at the speed of light, first of all, normally all of the matter in his body would just instantly turn into energy. That's the barrier. They call it the light speed barrier because physical matter at the speed of light just turns into energy and it's not physical matter anymore.
Yeah, so he wouldn't age because he wouldn't be around no more.
Well, even if you were traveling near the speed of light, that's why time is relative. You wouldn't have to break the light speed barrier to notice that time difference, though. You could travel at a third the speed of light and you're still saving that much time. You see what I'm saying? Okay, so now here's what I'm trying to explain about the speed of dark. And people are like, the speed of dark? Yeah, well, I don't take a lot of credit for this idea. It wasn't my idea. You know, a lot of the ideas that I talked to you guys about weren't my ideas. I've read and I've studied a lot, you know. So here's what's up about the speed of dark. Let's say that you shine a light, whether it's a powerful laser or not, that covers the whole surface of the moon, right? Now, from one side of the moon to the other side of the moon is roughly what? About the size of the United States. We're going to say a couple thousand miles, right? Okay.
Yeah.
So you're looking at the surface of the moon. Now, it is impossible for light to reach from one side of the moon to the other side. Let's say you were standing on the surface of the moon, right? And you shine a light from one side of the moon to the other side of the moon. Well, it's going to take so much time to get there. Okay. But if you're standing from a third perspective, like the Earth, and you shine a powerful light onto the surface of the moon, okay, and you wave your finger in front of that light, okay, the shadow of your finger just crossed the surface of the moon faster than the speed of light could from point A to point B. That's why the speed of dark is actually faster. The lack of the information of light is actually faster than the information of light itself. So this shadow that's cast onto the surface of the moon can travel from one end to another end much faster than the speed of light itself can. This is a proven theory, and you can look this up. Michael from Vsauce, The Speed of Darkness. It's an excellent video, and I recommend you guys watch it.
Yeah.
So there are things that can transcend the speed of light, but we're talking, and when we talk about the speed of light, the assumption is that we're talking about humans in a little vehicle going faster than light, you know, because that's the fantasy. That's what everybody wants. The deal is because of space-time, and you could even almost call it like, remember how I said space-time is a fabric? Well, imagine as you approach the speed of light, with space-time being a fabric, the friction of this fabric upon your very being. And that's basically what's going on. So space-time is carpet burning you back into energy if you travel at the speed of light.
Don't carpet burn my nips.
Right. So, I mean, that's what's going on. As a physical object approaches the speed of light, it breaks down into energy.
Yep. And therefore, that's why I say that the argument about time slowing down is invalid, because your test subject would no longer be a test subject. He would turn into energy.
Well, Einstein's theory, he had some out there theories, but at the same time, you have to look at how intelligent Einstein was. Einstein's theory about traveling forward and backward in time was somewhat simplistic. Well, he's like, if you can go forward and you can save all this time with time being relative, well, what if you just traveled backwards the other direction around the Earth at the speed of light? Then you could travel backwards in time. This simply wouldn't work. In space, there is no north, south, up, down. You just decide which direction is what. There's Mars. There's Saturn. That's the direction I'm going. You know, there's no gravity in space, because when we look up at our ceilings, most of us are in America, I'm assuming. What a lot of people don't realize is, and this is where I'm going to call the flat earthers out, you know, in Australia, okay, their ceilings are, you know, of course, to them, it's up, right? But, you know, we know by how the world works and people are standing on the ground and the way their houses are built, they're not living upside down in Australia. They're living right side up.
See, that kind of fuels a flat earther, because a flat earther believes Australia is still on the same longitude or latitude as us.
I mean, I'm not trying to fuel the flat earthers here. My deal is this. I believe that no matter what a person believes, that we were all given the rights to walk this life and believe what we want to believe. Even if that thing defies all logic, people still have the right to believe that. So I'm not here to fuel flat earthers. That's not what it is. I disagree with the flat earther mythos. I disagree with what they believe in, but they have the right to believe it.
No, what I'm saying when I said that it would fuel their arguments is they believe that the Earth is a. All right, you remember playing board games when we were little?
Yes, I call them board games because I would only play them when I was bored.
Well, the Earth is that board, and the whole of all of the continents is on the top of that board.
So what's on the bottom?
The firmament.
But the firmament is the land. Now, I can agree with flat earthers to a certain extent, but when they start messing with the definitions of words, that's where I got to call BS.
Yeah, that's what they would say.
I
mean,
it's like a firmament, right? Okay, if you're in a boat and you're traveling in water and your boat strikes a firmament, it's not striking more water, it's striking a rock or some coral or some land, something solid.
Yeah, see, I'm the one that come up with the idea that it's actually water because if you look at it, the upper atmosphere contains a whole lot of water, and below the land is sea level where there's more water.
Well, I mean, if you just look at oxygen, the very nature of oxygen, what does condensed oxygen turn into?
Condensed oxygen turns into water.
Exactly. So, I mean, like, you have to look at I would almost say that there's gravitational tears, right? The reason that we have water in lakes and the reason that they call it sea level, right, is at that gravitational instance, okay, that's where water condensates and forms into bodies of mass. Okay. Above sea level, there's not enough gravity to pull all the oxygen down. And so it's a gas instead of a solid. My deal is I think that the only reason bodies of water lay like they do is because of the gravitational pull of the earth.
The thing that I learned in fluid mechanics when I was learning about hydraulics for machinery is okay. Water will always seek the lowest point.
Yeah, I think I remember something from the Pocahontas cartoon. There was a song sung about that.
Yeah.
Yeah. A dude, an Indian dude telling his daughter, it's like, just do whatever you have to do. Whatever gives you the easiest life. Don't strive. Like that's real great dad advice there, buddy.
Yeah, but water will seek the lowest point no matter what.
Well, that's just because of gravity, though. I mean, look out in space,
I'm not denying gravity does it, but it will seek the lowest point. So
the actual statement here is if you take water and you pour it down a rigid object, it's going to take the easiest path to the bottom. It's not going to take the most difficult. It's going to take the easiest path.
Mm-hmm. Yeah, definitely.
With the least resistance.
Definitely.
So guys, I really have to say this. This is the first video we've done in a really long time. It's been so long since we had made a video that I didn't even know if I had it in me anymore. It's literally been the most part of a year since I've made a video. I just wanted to come on. I wanted to talk science. I wanted to argue with Tate just a little bit. I had fun doing this. I'll probably do some more in the future. If you guys really do like this video, if this was enlightening for you, if you had fun, let me know in the comments section and I'll probably do a few more. It's just at this stage in making YouTube videos, the only reason for me to do it is to please you guys, right? I don't have 1,000 subscribers. Nothing I do is monetized anymore. I'm not making a penny for doing any of this, and the only reason to do a YouTube video is for you guys. So if you guys like it, if this is what you want, let me know and I'll do more. And I'll be happy to do more. I just need to know there's a reason to do what I do. That's all I'm asking, guys. Um, it's been fun. Um, let me know what's up in the comments section. I'm not even asking you to subscribe because look, if you guys like what I do, you probably will. If you don't, you probably won't.
Hey,
Um, yo,
I got an idea for you.
what's up?
Why don't you start a Stump SP section?
Oh, people can't stump SP. There's no way to stump me because if I don't know the answer, I'll make something up, dude. I'm just saying.
No, like invite them. Like, hey, you want to try it?
I mean, if that's something people would be interested in, I mean, that's fine. I mean, I welcome people to try to challenge me on a scientific level. But at the same time, with the whole stumping SP thing, one of the most important lessons I learned in science is that to respect everyone's mind, even if you don't agree with their opinion, they've got a right to believe that, you know? So a person could approach me and say, not only is the earth flat, but the earth's core is made of cottage cheese, and where I'm coming from with it is like, if it makes you happy to believe that the earth's core is cottage cheese, then I've got some pretzels and some crackers, brother. We'll go at it.
That sounds tasty.
You know what I mean? I'm not here to force people to believe like I believe. I'm just here to talk science because I love science, and maybe the people listening love hearing about science, and that's all I'm about.
Well, I've learned open debates do gather attention, and it is fun.
You know, I do love a good debate. I mean, if people want to come to me with their scientific theories just to see what I think about them or just to talk to me about it, I welcome that. I never, you can ask Tate. I never tire of talking about science. There's been many a times I've called him at 3 o'clock in the morning to talk science, and he's just like, "Oh my God, man. Oh, you know,
And that's where I normally tease you and tell you alchemy is the forefather.
alchemy is not the forefather. Alchemy is the weird uncle."
The weird uncle that touched science.
That's right. And science has a lot to say about that.
Anyways, man.
But yeah, it's been great. It's been so long since I made a video. I just thought, and this will probably be all there is to the video. I may not edit it, I may not doctor it up, I may not even shoot a thumbnail up because the meat of what me and Tate do is what it's always been. We talk. We talk about things. So it's not about pretty pictures or pretty titles or this is kind of what we do. And if you guys like it, we'll do some more, you know. Until next time, remember, this part of it is important. If you like this science conversation that we had, or the talk that we had, let us know, because YouTube's not playing friendly with us. They're not playing friendly with a lot of people. And there's honestly no reason at all to do this ever again if there aren't at least a few people out there that enjoy what we do, because we're not making anything from this. Until next time, this has been SP. Is there anything you'd like to say, Tate?
No, not really. They know where to find me.
Right on, right on. Thank you guys for tuning in. It's been great, guys. Peace.